Okay, lesson 1.6, algebraic translations. This is just taking words and putting them into either an expression or an equation. Okay, so where a lot of times all you have to do is read the words and kind of annotate it. So the phrase, the quantity indicates the need to use parentheses. So if you see the quantity, that means you're going to put that quantity or those words, translate them into variables and numbers and put parentheses around them. The phrase a number refers to a variable. A number, we don't know what that number is. So we put a variable in its place because it's called an unknown. All right. Is often refers to equal, but not all the time. Okay. So, but most of the time it's equal. Less than and subtracted from, it's the second number minus the first. So a lot of times if we see less subtracted from 7, we would put 7 minus. Yeah, or we would put something minus 7. But in this case, the second number would come first. And so when we come across one like that, I'll refer to it so you know what I'm talking about. When choosing a variable, try using a letter that corresponds to the unknown. For example, when asked for a number, then the variable n could be used. Does it have to be used? No, but then that kind of correlates with the words you're using and helps you to maybe kind of correlate your words with your variables. When asked for the perimeter, you could use P. Okay. When asking for cost, you could use C. A formula is a rule expressed in terms of algebraic variables. So for example, if you want to know the formula for the perimeter of a triangle, S plus S plus S. Remember, perimeter, you add up the outsides. So each side. Area of a rectangle is base times height or length times width. So you could put or area equals length times width. Either one works, okay? And then the volume formula is volume equals length times width times height. I put these here because you may see them in your homework, okay? So refer to the notes. And then here I have some examples. So the sum of 3 and a number means that you're going to add those together. Now notice there's two different ways because we learned in one of our last sets of notes that there's a commutative property of addition and multiplication, meaning it doesn't matter the order when you add or subtract or multiply because you'll still get the same answer. But it does matter the order of subtraction and division. That's why it's very careful to pay attention to the wording. 7 more than a number also means adding. A number plus 2 also means adding. A number increased by 8 also means adding. So all of these are adding phrases. Okay. So let's go down to some examples. 5 more than a number. So 5. And then we said that more than means addition, and we could use n for the number. So this would be 5 plus n or n plus 5. 17 decreased by a number. So this one would be 17 is being decreased by some number. Okay. Notice how I'm just writing above it. There are some exceptions to this. 3 less than a number is an exception. Remember up here, we said less than, less than, that means the second number is going to come first. So anytime you see less than, your second number will be minus the first number. So in this case, 3 less than a number, you're going to switch your n and your 3 because your second number comes first. So this one would be n minus 3. Pay attention to this because this will show up several times in your homework. Because you're taking 3 from the n. It's 3 less than that number, okay? 1/2 of a number is 5. So 1/2 would be written as a half. Does anyone know what of means? Yep, multiplication. And if you look up here, of is right there. It means multiply. So we're just going to put a raised dot. I did see some people still put an X. Don't use the X with multiplication. Of a certain number is means equals and then 5. So I'm going to write this. Now, because there's a variable here, I do not have to do a raised dot. I could just put my half and my n together. So this one would be 1/2 n equals 5. Does that, any questions? Yes. Um, which number? Yes. Okay, so what she's saying is because this is 1, only when this is 1, you could do n over 2 equals 5. So I would take either one. Okay. You're welcome. The ratio of a number to 7 is 21. Does anyone know what ratio references? Divide. Ratio is divide. So let's see. Is that in here? No. Oh, that's addition. Let's see. Ratio. Ratio is not here. So let's add that to the bottom. We're going to add ratio to division. So the ratio of a number, so ratio means division, to 7 is 21. So we would write this, and remember, we don't want to write the division sign. We want to write it as n over 7 equals 21. Okay. So ratio, when you were in 8th grade, you might have done ratio as like 2 to 7, 2 to 7, or 2 over 7. But all of them actually represent division. Okay. All right. The sum of half a number and 15 is 24. All right. This is where sometimes the words you have to mix up the words a little bit. So the sum of these two numbers is 24. Does anyone know where we would put, first of all, sum means addition, right? So where would we put that addition symbol? Okay. Yeah, between half a number and 15. So we have half of a certain number and 15 is means equals and then 24. So that sum means that you're taking the sum of these two numbers. So let's write this out. Half of a number and 15 equals 24. I would like for you to try to do 7 through 10 with your partner or on your own. And then when we come back, we are going to check this. First of all, though, what does product mean? Multiplication. What does twice a number mean? Multiplication. And what does quotient mean? Division. All right. So go ahead. I'm going to pause the video. When we come back, we'll fill these in. Okay, so if you're listening to the video, you can kind of fast forward just to check if you're correct. But I'm going to ask the class, does anyone want to volunteer example 7? Jacob? I'm sorry? Minus, okay. So it's saying, so you said minus? Okay, here it says sum. Plus, okay. So 7 times a number and 5. So that plus goes here where the and is. And so we have 7n plus 5. Good. All right. Does anyone want to try number 8? Evelyn? Yes, 4n minus 2. So let's see. 2 less than. You're seeing that less than means that you're second number comes first. So less than the product of 4 and a number. Product here, you're multiplying, comes here. And so then you need to switch these two when you have less than in the term. So 4n minus 2. Perfect. All right. Anyone want to try number 9? Go ahead, Caitlin.
Is it 2n?
Yep, 2n minus 1. So this is the difference of, so difference is going to come right here. 2n, oops, right here, and 1. Okay. All right. This one is a two-step equation. And most of these are expressions, some are equations. Anyone want to try this one? Okay. So this says when the quotient is division of a number and 3, so this is number and 3, quotient will come over here with and, is increased means addition, by 10, the result is 4 times the number. So I just wrote everything in. The only thing I had to change was putting the quotient where the and is. So then the final answer here would be x over 3 plus 10 equals 4. Oh, wait, I'm going to use n. I'm going to be consistent. 4n. Okay. All right. Any questions on that? Okay, let's go ahead and go to page 2. Page 2, we're dealing with geometric formulas for the most part. So some of them are not, but I do have the formulas here. Some you will need, some you will not. So whenever we're dealing with a word problem that requires multiple variables or a formula, you must always write it out. That would be a point towards your problem. So if you don't write out the formula, then you lose a point. Also, if you don't use the formula to solve it, you lose points. So I don't want to just see chicken scratch to the side. I want you to act like trying to figure out the answer. I actually want you to write out the expression or the equation. And then if it asks you to solve, you can solve. Sometimes it won't. So you write out the formula, then you substitute any information given in the problem for that formula. You will have one variable left that you will need to solve for. So let's see if these don't look like ones you have to solve for. So we're just gonna write out the formula for these, okay? So again, we can annotate here. So this says state the cost C, they give you the variable to use, in cents for n gallons. So n is going to represent gallons. Now, if I were doing this on my own, I would use G for gallons of ice cream at X cents. Okay, so we have the variables. We just need to figure out what goes in between those variables. So when we talk about cost here, our cost is going to equal how much ever we spend, right? Or on this side. So what do you think will go in between our C and our N? Equals. And what are we doing with the gallons and the cents? That's kind of confusing. Let me give you a different way to word it. The cost for a gallon of gas is $3.50 a gallon. But we don't know that it's $3.50. I don't know why we put cents because gallons is not cents. Gallons is dollars, but whatever. So if I were to say it's $3.50 a gallon, what are we doing with the dollar amount in the gallons? We're multiplying. So if we have a certain number of gallons, oh, this is ice cream. We must be buying a very small ice cream, not gas. But it says gallons of ice cream. This is not a proper question. Anyway, we would be multiplying those together. Okay. So, well, when we have two variables next to each other, how do we write that? You could use parentheses, or you could just put the two variables next to each other. So this would be C equals NX. I'm going to mark this one and change that one up a little bit. Okay. Example 12, the distance in feet an object falls, so we have D, is equal to, just put your equal to, the product of 16 and. So if we have the product, we know that product means multiply, right? Wherein we have 16 right here. Where is that multiplication symbol going to go? Anyone? Yeah. Right, it's going to go right over here where the and is. So we're going to move this. I'm going to run out of space, but we're going to move this right here. Now, so let's reread this. The distance in feet an object falls is equal to the product of 16 and, okay, the square of the time in seconds. T squared. So T squared. I'm going to write this in my darker color so we can see it. All right, so let's put this all together. D equals, we moved the multiplication sign, so we have 16 and T squared. Now I don't need my raised dot. I could use parentheses, or I could just write my T squared like this, okay? Notice that a lot of times those operations go where the and is, okay? All right, let's look at the next one. The Fahrenheit temperature F, so I'm going to put an F right here, is equal to, I'm going to put an equal sign here, the sum of, so we have sum of 9/5, I'm just going to write 9/5, of the Celsius temperature C and 32. We have C and we have 32. Where does the and sign or the plus sign go? Where the and is. So we're going to move this right here. Okay. All right, let's go ahead and write this out. Fahrenheit equals 9/5. Now, one other thing is that we have to put C and 32 in parentheses. Okay. Because we're taking 9/5 times this sum. It's not 9/5 times C. It's 9/5 times the total sum of these two. Okay. So that can get a little bit confusing until you get used to it. So probably on this homework, I'll give grace on this, but then check your homework. If I put parentheses around it, then next time you'll need to put parentheses. Okay. What I am going to do is I'm going to have you work on the next two on your own. And then I'm going to do 16 and 17 with you. So I'm going to pause the video. You guys work on 14 and 15, and then we'll come back and we will finish this up. Okay, does anyone want to try 14? Go ahead. Yeah, go ahead. Yep, PRT. That's an actual formula we're going to be using. This is a degrees formula, distance formula for quadratics. We won't use that much. This isn't a regular formula we use, but this would be a formula we would use to solve like a world problem. Okay. All right. So if you're wondering how we get this, it's I is equal to now the product of all three of these together. So P, R, and T. Product is just, you're going to multiply all three of those together. All right. Anyone want to try 15? Okay, Julian. Yep. D is equal to 1.39 Q. All right. And so I'm going to annotate this. D is equal to the product of 139. Product means multiplied. And so we're going to put that multiplication symbol where the and is, and then Q. And that's how you get that. Okay. All right, let's do the next one. I put my line is way too off here. Sorry. Okay. All right, so we're going to state the cost D in dollars. So I'm going to write D right here. For K kilowatt hours of electricity. Okay. If there is a flat charge of 12. Now, this is something different. A flat charge of 12 would be, it's just by itself. You're going to have to pay $12 regardless. Okay. And then, and means in addition to that 12, you have to pay 8 cents per kilowatt hour. So how do you think you're going to write 8 cents per kilowatt hour? What operation is that? Multiplication. So it's 0.08. Now, what variable are we going to use for kilowatt hours? Well, it's actually given to us in the problem. Look up here. Yes, I heard it. Kilowatt at K kilowatt hours. So they actually give you the variable. So this is going to be K. So your K is actually being moved down here. Now, where is our equal sign here? Yeah. After the D. So this one would be D equals 12 plus 0.08K. And I forgot to put my plus right here. So you're taking the $12, and in addition to that, you have to pay 8 cents per kilowatt hour. Okay. Okay. State the total expense T of buying a car if the purchase price P and 6% sales tax is charged. Oh, we have a percent in the problem. When we write equations, do we put 6%?
No.
0.06, you change it to a decimal. So P and 0.06. Okay, we're missing our operations. So the total expense is going to equal how much we're going to pay. So we have to take the principal, and what are we doing with the principal and the tax rate? Okay. Let me explain it this way. We have to pay the principal. So say that, okay, we're going out and we're buying a car. And honestly, I would say that this is not a problem that I would give to ninth graders because you don't drive yet and you have not purchased a very large item. Okay. But did you go out and purchase the vehicle?
No.
Did you go with your parents to purchase the vehicle?
Yeah.
Okay. So this is how it works. When you go out and you buy a car, you have to pay for the car. So say the car is 20,000 on the lot. By the time you get in to purchase it, you're going to have all these taxes and fees, and it's going to probably be close to 25,162. I'm just throwing a number out there. So you have to pay 21,000, what did I say? $562. But in addition to that, so listen to the word addition, you have to pay another 6% on top of that principal. P plus 6% of what? What'd you say? That is the sales tax. It's 6%. Juliana?
Is it P plus P times 0.06?
Yes. So your total cost is going to be the principal, right? And then in addition to that, you have to pay 6%. Oh, wait, that's 0.06 on top of the principal. So you're going to take that 25,000 or 25,162 times 6%, and you're going to add that to the principal. Okay. So can I show you real quick what that looks like? I know you want to stop, but this is actually a good lesson. So I'm going to show you on your calculator. Now you don't need your calculator because it's not asking you to solve. But if I took 25,162, do you think that when I take 6% of that, it's going to be less than that number or greater than that number? Think of it in your head a little bit. Okay, and let's see if you're right. Times 0.06. It's less than. It's $1,509.72. That is the sales tax rate that you will pay in addition to the total cost of the car. So now I'm going to add that to the total cost of the car. Yeah, so then you would end up paying $26,671.72. When you go out to purchase a car, don't take the sticker price at face value. And when I say sticker price, that's the price that they show you out on the lot. You're going to have to pay a lot more. So this ended up being $6,671 more than what you thought it was going to be. Okay. This is the same as when you go buy anything in the store, you have to pay a sales tax price. So if you go buy a shirt for 20 bucks, is it going to be 20 bucks? No, you're going to have to add on the tax for it. So that's how you add on tax. I'm going to give you just this example. What is the tax rate in Texas? Is it 0.825? What is it? Let's see. I can't remember what it is, so I'm going to look this up. It is here.
No.
What is the sales tax rate in Texas? Okay, let's see. 0.6 or 6.25. Okay, so let's go back to let's share my screen with everybody that's watching. This may not be interesting to you, but I think it's interesting because it's something that maybe when you start working and earning money, you can maybe start to help yourself figure out the cost. So you want to buy a shirt. So the total cost for your shirt is $20 plus a 0.0625 tax on that 20. So let's see what that's going to be. We're going to have cost equals 20 plus. So I'm going to take my calculator, 20 times 0.0625. You're going to add another $1.25. So the total cost for your shirt is no longer $25, but $20 and $21.25. So that's kind of how that works. Okay. All right. Thank you for bearing with me with that life lesson. And that concludes our notes for lesson 1.6 algebraic translation.